yeah, I'm building back the system together, but I notice I have like 2 PCI. They have like 7 pins, but on the other side it's actually 8. I have no clue how they do that. They make one cable into 2 or something. That's genius. But problem is I have 2 of these for GPU. Theoretically speaking, I would have that connector, right? But that connector on that graphics card, it's a different connector. And the cable they put with is the original cable with the 18 pins or something plus 4 pins. And on the other side the same. 600 watt connectors, and they didn't put a second connector like on the ASUS store, which is not spinning any rotation. They didn't have the second connector with PCI adapters, but the ASUS store had one of these, and it looks like that. No, that's the original one. I don't know where the other one is. But the board I have has actually 2 8-pins and another 8-pin. That one has just one 8-pin, and that board has 8-pin and 4-pin. Nothing else except MRTX Molex, the big one for mainboard. But I have 2 cables for the graphics card. These are inserted here. I have another one which seems to be a little bit thinner than these. I don't know why, maybe that's some illusion. But I have another cable from the ASUS store for PCIe, which PCIe to PSU is not CPU. I was on the search for maybe a cable like that to go into 2, but I don't really need that. I need one more of the PCIs for CPU. And I was on the lookout in my whole room here, and I found that cable. I was remembering, and after a minute or 2 minutes of search, I found the case of that, the PSU, and there's no cable inside. There's no cable inside. There's no cable here inside. Here is the nothing, basically. That's the nothing. There's no cables, and in that one is the old AC power, no silence power supply, which is non-modular. I can't use any cables of these, even when they look garbage. I wouldn't actually use these, but I can't use any of these. And I was rooming in my room for a couple minutes. Then I thought I probably don't have another cable. So I'm basically missing now a CPU connector from PCI, but I actually also did not found the 8-pin connector from the ASUS store, because that comes with 2 8-pins, I think. I think that has actually 2 8-pins, but I didn't found it either. That was really, here it is. That's the connector for the graphics card, but I don't need that. You can't put that into the CPU because it's PCI. Here, what's that? That's for the PSU, and that is for CPU. I will just use that, so I can leave that system on. Maybe I'm lucky and I find a white cable right under there. Maybe I could find other things. A backpack. But the problem I have right here is that this cable is a little bit too short. The cable is too short. Let's measure how lengthy the other cables are, and it's basically the same. So that's the problem. It's not long enough. That's going down on the mainboard either ways, so that's not the problem, but getting these up is probably a problem, since that case is even a little bit higher and bigger than that one. So theoretically speaking, I would need to use the old extension cables I had installed in my system. I don't really want to do that, but I probably have to. So I have these Georgius huge length extensions cables, oops, from Surlier, I have no idea, some flies, shit, probably through the quantum system of the cables. Thank you. That's really weird. Actually, I use these lengthening cables for the mainboard above the graphics card. Don't need one. It's lower height. It makes sense, but something is weird. How is it called? Weird in my brain. But lucky-wise, oops, something fell down. This side cable and this side cable has full pin slottage. That means every pin actually transmits. So that's quite cool. So I don't need to worry that my 7 pin to 8 pin to actually 8 pin connector does send the electricity right, I think. So that's the cables. Oops. That's the cables I requested. That's lengthy enough. That's super long cables. And that is for SATA. How many do I need? 1, 2. And that's probably it. Maybe I don't even need SATA here. No, I don't even need SATA there. I just need SATA there. But the shit on this PWM controller is I actually forgot again, and I don't even have the money to apply. I could use the old one. Would eventually work, and the controller has do the PWM freeze locking. Maybe that would work, but that has actually old settings, and I don't really like that. And the other controller is basically stressed as every component here, either ways. I would say it's when it's stressed, it's actually destroyed. But the PWM here has 2, and that is, I don't know, that is SATA. That is actually, ARGB also 2 pins. That's quite garbage. I don't really know why I thought that one would be better. When that would be ARGB in, that is ARGB 12 or fan 2, fan 1. There is NC, okay, fan 7, ARGB 7. So the ARGB in is also 2 pins. I don't think that would be better. But when that one would have had like 3 pins, that's also 2 pin, yeah. When that would have 3 pins on ARGB, I could eventually use that one, because the 3 pins on the ARGB for synchronization is actually important. But that one doesn't have it. It would have, when it would have like the ARGB 3 pins and the reset button, I can include the reset button, and over power in 4 pins goes the SATA. The SATA is split to 4 pins. Not necessarily the best, since the ARGB is 2 pins. On 3 pins on this hexanet would be working, but also configuration thing could go confusing with Bluetooth and stuff. So let's better break it down and make 2 pins out of 3 pins, so the configuration slows down into crashing down the system is way easier. And PWM in is 2 pins, so I can use the 2 pins there. It's not really a problem. And that's ARGB 9 and PWM 9. I could use lighting system on this one. Usually the lighting systems goes on that side and the processor goes on that side. Usually that is actually not for the processor, but for the PWM freeze lock situation. But most systems, you could imagine to put the CPU fan on the freeze lock, since the CPU fan has and needs actually the data, and the CPU fan should like guide the PWM freeze lock, but that's actually not how it's happened. But maybe on one or another device you could be lucky with the 2 pins, 3 pins SATA insanity system, that your CPU fan could actually defreeze lock your PWM, because you have like SATA connected in, and your CPU intelligence here, and the PWM from the CPU, which goes to the main board. I don't know, I think I would connect that usually to the CPU, and then the CPU fan inside there, and yeah, that's another issue. Like CPU fan and the case fans on CPU fan connection with 2 pins is like, I don't even get any words for that together. In the case you would put like the PWM to the case fan, would be working, but you would need to have like the CPU inside here, and the CPU signal is not arriving. So the case fans come in, so you don't get any freeze lock defreeze lock signal, which you would need a second connector, which is 1 pin or 2 pins at least, to put into the CPU fan, which would be cool since these are actually for CPUs and these are for cases, and these are for accessoire lightnings like LED bars and stuff. So you could actually connect case fan, PWM in case fan, and another PWM in for processors, so the freeze lock system actually gets any data, but it doesn't. You can put the PWM in to processor or case, and the device is calculating for it how it's responding, and it's better to connect the CPU fan PWM out to PWM in to these devices, but that's just 2 pins. That's insufficient for any like organization of the board, and you have to be lucky that like the fan systems like Q fan tuning or something is intelligent enough to tune the PWM sockets into the board and then find communication lines on the board where the fans are socketed in to the PWM out, which is then just the PWM for CPU, and then the pin is just the adapter is just 2 pins of connectivity, and the sockets you have on the board is limited by the freeze locking situation, and the only thing what this can do is basically just defreeze locking it and then just doing the fan and RGB thing, which when they do, that's probably working, but you probably still lose tons of sockets of your fans, and the fans lose communication lines for SATA and NVMe's and stuff, and the voice system is like schmelzing. It's schmelzing together to care for the freeze lock, and when you put that to the case, actually let's try that out. When you put the PWM to case fan, that is that. Okay, that must be the one that's for case. I will slot that is it for? That's three pins. 3 pins for fan PWM, for case and processor. I will find a CPU fan connector and put that right in. Maybe let's see how the system is reacting then. The fan here is lighting up, that's a good sign. The SSD is lighting up, also good. But the case is not lighting, that's bad. It's not lighting, it's not spinning. I don't think that did something, but was a try worth, right? That's some Asus release, Asus TUF. And the Wi-Fi card is on, not bad. The RAM goes on, the fans are spinning, the NVMe card is actually activated, VLAN card is activated, but the power supply is not activated. The ACPI controllers sense, I don't really know what's actually happening there. Let's turn it off. It's still sending the red LED sign. And A2, B2 is fail configuring. A2, B2, depending on where that is probably still the graphics card. I will put the graphics card out for a second. The graphics card, the sound card has actually also power supply connectivity. There was no signal, I think. Yeah, and that signal, that sequence signal, that is not usual. When I have that card inside, I basically don't see that, and that that right there is, I think, the Molex there actually tried to reach the device, and that actually asked, I think, the PCI. I think it's actually asking the PCI 16 on that fail message. But also not spinning. The problem is just that with that ACPI controller with just two ARGB is messing up massively. When the PWM in would with just two wouldn't be that bad, that's tuned in for two, but the ARGB needs actually three, that's quite bad. But maybe I will just connect that to that one here. That's the synchronization spot. I don't know if that's actually working, but I will connect that one to this MB synchronization motherboard. Maybe it's working because it actually says motherboard synchronization, and that one is actually a motherboard synchronization since the signal taker is actually here. That's synchronization or extension. Maybe it's an extension, but it looks like synchronization. And that one is actually a motherboard synchronization. 2 pins, 3 pins, ARGB. Could be working, would be better. But I was worried actually a lot because I got the TPM switch and I got hit by the idiocy systems here, like the thermal systems we have inside the city, where this Dali doctor is, the heating Kraftwerk, and the heating Kraftwerk is basically worse than nuclear plants. Actually, this heating Kraftwerk can be utilized for sending heat bombs or something into the future of 20 years or something, and these were quite bad in the city. And I literally just forgot. I got hit by the idiocy problems by these talkings right there, J, SPE, and TPM SPE. That these SPE headers are actually not compatible to SPE TPM chip modules, which actually write APC on it. I'm searching right now for the module. Should be here somewhere, I think. I write on that book. That right here is a Infineon, I think. Infineon, that's a small one. So the 9670 or 65. Yeah, I see the 65 can have troubles with that, but that's Infineon SLB 9665, and that is a SPE-based TPM module, even for ASUS. And I tried it on that ASUS mainboard, and it started getting hot. On the BioStar the same, but the problem is that SLB 9665, which is a SPE TPM module, which is even TPM 2.0, and that is the 2.0 board, it said that LPC modules are for old computers, and old computers where it said this use APC use usually TPM 1.0, 1.1, 1.4 or something, and they don't use TPM MR 2.0. But actually I use the pins with 2 pins header extend, and the one with 2 heads header extend have usually here plus and these two are plus, and here's ground or there's ground, and I use the wrong header pin solution even when it's like fitting there. You can slot it in and think maybe the chip is aligning or something. It doesn't, because probably it's actually even getting directly hot. Even when I don't put on the system or something, it's getting hot. It's crazy actually. And the problem is that these grounds are connected to somewhat to power adapter of the processor or something, so the ground of these are actually getting energy from energy pipeline socket of the processor, and I get energy from there or something right into there, while it's a ground pin. The ground pin takes the energy, and the V3 pins partially can be that it's on the place of one of the synchronization networks, and it asks for energy on these, and these can give also the energy, so it's getting energy without like grounding solution, and can be that chip is like grounding then, or that chip is grounding, or something around here is grounding, that PCI card is grounding. Since there's actually that PCI slot in, that board didn't take fire, because when that wouldn't be in, there would be a grounding pin less, and that slot is eventually taking off the ground situation on that chip, and wouldn't that be here, that chip would eventually flame up, or the board would be destroyed. And the problem I have here with the synchronizations, when I would put that actually on the main board, I could be ending up very unlucky, so that where did I put it? Now there. I could be unlucky that when I use that pin header on that main board, which luckily has the same pin amount and the right direction to slot it in, that still with these PCI adapters, which I will have to use one from another brand, but I could be unlucky that these with that ACPI solutions still make that the TPM switch is going on fire, and that would be really bad. That module costs 43 euros on Amazon, and I actually need that to work, because the PWM fan system is quite cool, but the ACPI controllers are complete garbage. You can't like use case and CPU PWM controls to put that in, while these controllers have CPU slot and case, and even for accessoires. So they basically have case, processor and light bus, but you can just put like 2 pins in, so you have decide on case or CPU, and then you have to decide on slottage. You basically slot the device into CPU fan PWM or case fan PWM, and that's disturbing a lot of the board. And these things, these managed PWM systems and freeze locks, since I inhaled badly. Since you can just decide on case or CPU socket in sending signal, usually these hubs end up just to be like freeze lock lockers. These are PWM freeze lock lockers, just which have power connection to the main board, to the power supply, which still ends up quite important for the RAMs, since they ask for on PCI to power supply if the connection is guaranteed or not. So that's quite important. But you see, when you put like CPU fan PWM in or case fan in, the CPU fan is eventually better, but you have then just 2 pins for ARGB, 2 pins for the PWM, and you have just the contact of the voice system asking questions of authority if it's authorized to do the command, and then the authority giver pipeline has just 2 pins to communication, which can just do the grounding and the pipeline for the socketing. The socketing pipeline itself, it doesn't provide for the framework of the sockets to send out communication. And then what's ending up with the system is that the fans initially go into freeze lock. The freeze lock is inside the system. When you are lucky, you can get the fans socketed into the mainboard before the freeze lock activates. When you are unlucky, the fans freeze lock and then socket in, and then you have 2 pins to release the freeze lock. But the socketing of the fan situation is integrated into the system. The system is already in post mode, and you can't change that anymore. When you are lucky and your Q fan control system is actually smart enough, it can actually deal with the situation and then realign them into the system. But when you are unlucky and have a bad controller, or use the case fan and the CPU fan on the controller, you don't have the debug mode freeze lock unlock signal inside the system, and the system is booting wrong basically without the freeze lock locked out. So so the fans can't really socket in correct into the system, and it's like falling off the hill and then staying there, and it's like an energy point where the window compositor is here, and here's the socket for HDMI and stuff, and here's your fan now. When you put just the PWM into the case out, but the PWMs just have 2 pins then. You can have like the freeze lock, communication, end lock, but it's not doing what I've said because it has just 2 pins. It can just navigate the pipeline for the socket FinFET and then freeze lock that pipeline, and that's completely different than defreeze locking the PWM fans into that place, and the fans end up in way worse places than what's that. And that's quite bad situation. And when the ARGB have just 2 pins, it's even worse than that. Usually that's actually a fire hazard, and I'm not 100% sure if I use that device, that the device is not going hot or not going in flames or the board is destroying. No one is really guaranteeing it, except that it's the right amount of pins and the right direction to put that in, and that I have actually some USB devices for processor debugging data inside that board then. That's so the USB debugger pins, which ended up just to be 4 pins. That's not enough to debug the system, but there's some debugging systems on there, and it works with with the CPU together, and the freeze locks can somewhere like rotate like a treasure, and your system is open. So the perfect system you have is open. You can play your games with, be happy and stuff. Other point is that I have an MCU that's ESP32 with a screen on it, which goes to USB-C, and that is a FPGA MCU, and this can help stabilizing your system for synchronization of the PWM freeze locks and stuff. But it's not necessarily said that these actually work. But since I have actually the right amount of pins and the synchronization ARGB, which is really helpful, I can use the ARGB to put to the board and the synchronization to that. So there is actually some framework support of the PWM fan fallback. That's the fallback place for window compositing, and that's the PWM fallback place. So there's some support for the PWM fallback, and these from USB-C usually go for the USB system PWM fallback, and they socket somewhere here. Eventually they socket here or something, and they can actually help too. But when I put that on that USB-C, that's basically in the normal 27 watts USB E key, I think. That would be actually good. 27 watts on these is quite cool, and that's 10 gigabytes per second, 100 watts. It's a different cable, I think, but that's a good cable for that device. And that's 27 watts coming out of there, which for that device is amazing. And it's also 10 gigabytes per second, I think. So that's enough. I think that can do like 5 gigabytes. It probably does like 7.5 gigabytes per second. So that would be quite cool. But I think that's actually not the right spot to use that, unfortunately wise. Maybe I will taken the device out already, I think. Oh no, there it is. Maybe I will actually use that device and connect the USB, and then connect the USB-C from there to the USB there over that one. So I have front USB and the front USB controller on the same USB. Could be good. Maybe I should actually connect it to that place, but I actually wanted to use the ESP32 on the front USB on that, but I don't necessarily like how that looks and works. Eventually it would be better to not use that port and use that connector for like these two controllers, and to have the TPM switch actually inside there, so the USB-C systems have bottom side like contact over the PCI instead of the triangulation of the chips. I don't really know about that and what is better actually to connect. So the probability of the TPM switch, which costs 43 euros or 40 euros around, when you want to have it fast, or usually you can wait for 2 weeks or 4 weeks and get it for like 20 euros or something, but I bought that for 43 euros, and I don't really know if putting like the USB-C to the lower USB ports, which have a direct connection to the power supply, which does help. The USB has basically a direct connection to power supply and can synchronize to the upper bird, and that eventually does help on the TPM in the case I would be just putting that in. But eventually it would be even better to have the front USB, not that one, but that one actually to that controller, so I can put that and that onto there, and another USB-C on that, and to put another ESP32 on that. Maybe that would be the best. But I don't really see what's working there or not. It's like titanium shielded. I don't really understand what's the difference, but then there's some problems which I don't really like, where I have fear that the TPM switch could actually take fire, which I really don't like, even when it's the right chip. That's a speed chip, on not the LPC chip, and that's not even the oldest, that's the newer one, and that's not even the newer one, which just says over I2C, and that is can do I2C, but that's a JTPM, and usually JTPM on modern boards is how everyone says, it's just speed TPM modules, so that's the right connector. But that's custom made, right? So that's and every fan system is different. That's also custom made. That is custom made. That is custom made. And even the switch is basically custom made. Nothing has to do with the MSI manufacturing. So basically, I can't even expect an answer for questions like that in any way. Either ways.